So we discussed the lesson, geometrical optics. You know how different types of optical instruments form different images. And then you know the way of drawing ray diagrams, and you all know what refraction, reflection, all those concepts are. Then we discussed the exercise from your textbook, and as I told you, that is not enough. You have to keep on practicing. So to do that, we have some extra questions here. So extra question 1. Select the correct answer. You're familiar with these types of questions. A parallel beam of light incident perpendicularly on a plane mirror is reflected. That you know. So there are two types of incident rays. One is incident perpendicular to the plane mirror, the other one at an angle. So when we say parallel beam, they are incident perpendicularly, and those rays go along the normal. Then how do they get reflected? They reflect in the same path. So as a divergent beam, no. As a convergent beam, you know what divergent and convergent are. Divergent, they go away. Convergent, they come towards each other. Perpendicular to the plane mirror as a parallel beam. That is correct. With an angle of reflection equal to the angle of incidence. That is when we have rays that are coming at an angle. Here, normally we have the angle between the normal and the incident ray. So here, the rays itself come along the normal. So there is no incident angle or angle of reflection. So the third answer is the correct one. Perpendicular to the plane mirror as a parallel beam in the same path. Then the second one. A plane mirror is hanging on the east side of a room. A person standing in front of the mirror and stretches his right hand. To what direction is the hand stretched in the image? So to understand this, it would be easier if we mark the directions. So you all know, if we have lines like that, this is the north, south, east and west. So here, according to the question, a plane mirror is hanging on the east side wall of a room. So this is the east side. So if the mirror is hanging on the east wall, so it's going to be like that. Then what happens? A person is standing in front of the mirror and he stretches the right hand. So if that is the east side, I am the person standing in front of the mirror and I stretch this is my right hand. So when I stretch my right hand, here you can see this is the mirror, this is the east. My right hand will be stretched towards this side. So what is that direction? That is the south. What is the question? To what direction is the hand stretched in the image? So first think of the properties of the image formed here. It's the same size as the object, same distance as between the object and the mirror, and the distance between the image and the mirror both are equal. And also it is upright, the same direction. But what is the special property? It's lateral inverted. What is lateral inverted? When you raise your right hand, it looks as if the image raises the left hand. But here, look at the question carefully. To what direction is the hand stretched in the image? So, I stretch my right hand, the image stretches the left hand. But both hands point to the same direction. So, when I stretch my right hand, the image also stretches the same hand. But this is right. I will use a different color so it's easy for you all to. So here the image stretches the left hand, but that also points to the same direction. That is south. So what is the correct answer? North, right, south, east. It has to be south. So remember students, there is lateral inversion in a plane mirror. So our right hand looks as the left hand of the image. Our left hand looks as the right hand of the image. But still, the directions don't change. If you stretch it towards the south, in the image also, the hand is stretched towards the south. Why? The directions won't change. So, I hope you understood this question properly. Now, I will move on to the next one. Always true about the images formed by plane mirrors. So, just now also we discussed this. They are always upright, real, lateral inverted. Is that correct? They are not real because you can't get the image on the screen. They are virtual. So, virtual, diminished, lateral inverted. They are not diminished. They are of the same size. Virtual, upright and lateral inverted. That's correct. Upright, not lateral inverted, real. So, those two are wrong. It is lateral inverted and it is virtual. So, the correct answer here is the third one. Virtual, upright and lateral inverted. Then the next one. What is the incorrect statement about a light ray incident on a concave mirror? Now, always when you read the question, earlier it was plane mirror. Now it is concave and that also mirror. What type of a mirror is a concave mirror? Is it diverging or converging? It is a converging mirror because all the rays that are incident parallelly on a concave mirror, they all get reflected and pass through the focal point. So, they all meet at one point. Therefore, it's a converging beam. So, it's a converging mirror. A ray incident on the mirror reflects in the same path. Does that happen? No. Now, I said parallel rays converge through the focal point. A ray making a certain angle of incidence with the principal axis are reflected with an equal angle of reflection. That is correct. If there is a ray coming at an angle, the angle is between the principal axis and the ray. So, it reflects with the same angle. That is correct. Then rays coming parallel to the principal axis pass through the focal point after being reflected. That is also correct. So, we said this is correct, this is correct. Rays coming along the principal axis of a concave mirror return along the principal axis after reflection. That is also always correct. Always the rays coming along the principal axis either reflect back along the same axis if it is a mirror. If it is a lens, they just travel along the principal axis. So, that is also correct. They have asked us for the incorrect statement. So, only the first one is the incorrect statement. A ray incident on the mirror reflects in the same path. That is correct only when it is coming along the principal axis. So, now I will move on to the next one. Characteristics of the image formed by a concave mirror. Again, look at the optical device. It's a concave mirror. Always upright, virtual, enlarged. Now, you can remember students, what type of an image is formed by a concave mirror. We place the object at different positions, you get different types of images. When it is between the mirror and the focal point, what do you get? It is an enlarged image, upright image, it's a virtual image. But when we have it on focal point, the image forms at infinity. Between F and center of curvature, C, then the image forms, but it will be inverted real. You bring it to C. There, the image will be the same size, again inverted and real. You take it away from C. What happens to the image? It will be inverted, real and larger than the object. So you can understand the nature of the image changes depending on the position of the object. So here, characteristic of the image formed by a concave mirror. Always upright. You can never say it's always upright, virtual, enlarged. That's not correct. Upright, real, enlarged, that is also at certain instances. Inverted, real, diminished. So all these depend on the position of the object. So depends on the position of the object. That is the correct answer. Then the next one. A virtual image is formed by a concave mirror when the object is, I discussed that a little while ago when we discussed this question with a concave mirror. The image is virtual when it is between the mirror and focal point. So between the mirror and the focal point, that is the correct answer. Between the focal point and the center of curvature, it's a real image. And also on the center of curvature, that's also real. Away from the center of curvature also, it's a real image. So only when it is between the mirror and focal point, it's a virtual image. The next question. Convex mirrors are used as side mirrors of vehicles because you all know that in convex mirrors, you can see the object. It is always the same type of image that is formed irrespective of the distance of the object. What type of images are formed? They are upright, the same direction, so it's upright. It's virtual, you cannot get it on the screen, and also they are smaller than the object. That is why when you have it as side mirrors of vehicles, you can see all the other vehicles and everything that is behind you within that small mirror. So all the larger objects look as smaller objects in the mirror. So it's a smaller than object image, or it is a smaller image formed. Real images are formed, that is not correct. Upright images of a large area is formed within the mirror, that is correct. Images are diminished and real. They are diminished but they are not real. Magnified image of the object can be observed. So here again, the purpose is to see smaller images. So the upright image of a larger area is formed within the mirror. That is the correct answer. Okay. So that's the correct answer there. Then we have the next question. When a parallel beam of light is directed onto a convex lens, the light beam, so here it is a convex lens. The reflecting surface is curved outwards, the same as the previous question. So convex lenses always reflect the beam away from a point. So that becomes a divergent beam, and when you extrapolate those divergent beam, they go and meet at a point inside the mirror or behind the mirror, and that point is what we call as the focal point. And the rays look as if they are coming from the focal point. So here, when a parallel beam of light is directed onto a convex lens, the light beam converges onto the optical center? No. Diverges? Correct. Converges onto the focal point? That is also not correct. Travels parallel to the primary axis? That is also not correct. So, they diverge. Diverges. So, with that, I will move on to the next question. What does not occur when a light ray travels from glass medium into air medium? You know what happens there. Glass medium, what type of a medium is that? It's a denser medium compared to air. So, air is the rare medium, glass is the dense medium. So, then what will happen to the ray? The ray has to refract away from the normal. Why? From glass into air. So, from glass into air, you can see this is a small incident angle, this is a larger refracted angle. That is possible. When you increase the incident angle, the refracted angle increases, and at one point, this also can happen. At that point, what do we call the incident angle? This is known as the critical angle. Why? The refracted angle is 90 degrees. So, that is another instance that is possible. Now, the third one. Here you can see this is the incident angle, this is the refracted angle, which is smaller. Is that possible? No. Why? Here in this diagram, the ray is refracting towards the normal. That is not possible. Then we have the glass, the incident ray and the reflected ray. Is that possible? Yes. When there is total internal reflection. So, what does not occur? Does not occur, that is this. This does not occur. All the others are possible. So, with that, I will go to the next question. The critical angle is 49 degrees when light rays refract from water into air. So, light rays are coming from water into air. The figure that shows the correct path of light when light is incident with an angle of 49 degrees when traveling from water into air. So, I am sure you know what critical angle is. Here you can see critical angle is 49 degrees. When the incident angle is equal to critical angle, what happens to the refracted ray? It refracts through the interface between the two media. So, here you know what has to happen. So, in this also the angle is 49 degrees. So, the first one from water to air bending towards the normal, that is possible but not with 49 degrees. Here it's going in the same path, that is not possible at all. Now look at this one, 49 degrees, it refracts away from the normal, that is also not possible. If you come to this 49 degrees, this is refracting through the interface. That is the correct answer. So, this is the answer. The critical angle is 49 degrees when the light rays refract from water into air. The figure that shows the correct path of light when light is incident with an angle of 49 degrees when traveling from water into air. This is the relevant ray diagram. So, with that, I will move on to the next question. Extra question 2. Draw a ray diagram to illustrate the reflection of light incident perpendicular to a plane mirror. So, this is to show how the plane mirror reflects light. So, a ray diagram to illustrate the reflection of light incident perpendicular to a plane mirror. So, to do that, first I have to draw the plane mirror. So if we draw this line, does that indicate the plane mirror? No. We have to show the reflecting and non-reflecting surface. So I will draw the lines here. So this side is the non-reflecting surface. This is the reflecting surface. Now we need to show a ray that is incident perpendicular to this surface. So I will use a different color. Here I am not going to measure or show the angles. I will draw a perpendicular line. So if we draw this straight line, I am sure students you have the ruler and you have drawn straight lines. For you it's possible. For me here I can use this option to draw the straight line. So this is perpendicular. So what is coming perpendicular to the plane mirror? That is coming along the normal. So how does it reflect back? In the same path. So here you can see it goes back in the same path. A very simple diagram. Then we have the next one. Draw a ray diagram to illustrate the reflection of light incident at an angle to a plane mirror. So that was the first type of ray. Now we have to draw the second type. I am sure you can do it before me. So you can stop the video, you can draw the ray diagram and then look at it with my answer. Now I will do the ray diagram. I will draw the ray that is incident at an angle to the plane mirror. So to do that, again I need to have the plane mirror. So I will draw the plane mirror here. So again we need to have the normal line. Before I draw the normal line, I will draw a ray that is incident with an angle. Now what do? We need to have the protractor so that it's easy for me to draw the ray. Right. So here this is the incident ray. I need to draw the normal line. So the normal line will be through this. At the point of incidence, this is going to be the normal line. So here, if we look at the angle, this is 90, 122. So that's about 32 degrees angle. The same way, if I take the angle here, 60, 62. At the 62 degrees, if I draw the refracted ray. So here you can see, you can also measure a certain angle and draw the incident ray so that it's easy for you to draw the reflected ray. So here I will have to take it through the 62 point. Right. So now I have drawn the two rays. This is the incident ray. This is the reflected ray. So since it says with an angle, you have to mark the angle of incidence and angle of refraction. So this is angle of incidence and R is angle of reflection. and you know both of them are equal. And what is this? This is the normal line or normal. So in this diagram, I have included all the necessary information. The plane mirror, incident ray, reflected ray, then the incident angle and the reflected angle. And you know they are equal. If you want, you can write that as well. I equals R. So draw a ray diagram to illustrate the reflection of light incident at an angle to a plane mirror. We have done that here. I am sure you also got your diagram correctly. Now I will move on to the next one. Extra question 3. Draw the path of the rays given below as reflected by a concave mirror. So here you can see the concave mirror is shown to you. We need to draw the path of light. So here you can see the ray is coming parallel to the principal axis. How does that reflect? It goes through the focal point. So we have to make sure that the ray comes to the mirror. So since it's a straight line, I am going to use the straight line option. It will go like this. So a ray coming parallel reflects through the focal point. Then this one. A ray that is coming along the focal point has to reflect parallel to the principal axis. So then to make sure that I draw a parallel line, again here the ray has to touch the line that is used to denote the mirror. Why is that? Otherwise, one person can draw the mirror, the curvature like this. Another person will draw a mirror with a higher curvature. Then at the point where you reflect the ray might vary. Then you won't get the correct ray diagram. So always we reflect it on this line. So this has to reflect parallel to the principal axis. So that is the reflected ray. So we have drawn the two diagrams. Draw the path of the rays given below as reflected by a concave mirror. Coming parallel reflects through focal point. Coming through focal point reflects parallel to the principal axis. The next one. There are other rays. So a ray that is coming through the center of curvature. You can see here C denotes the center of curvature. What is the relationship? This, the focal length and the radius, both that is equal to twice the focal length. This total length is equal to twice the focal length, or this length and this length are equal. I am sure you know that. I am just trying to revise what you have learned before. So a ray coming through the center of curvature, what happens to that? It reflects back in the same path. So again here I will draw the ray up to that point. But here if we show an arrow, that is more than enough. The ray coming through the center of curvature reflects back in the same path. Then we have the next one. A ray that is incident with an angle I has to reflect with the same angle, that you know. So to do that, I will use the protractor. So here again with the, students, as I told you all, when you draw, you will be drawing very thin lines so that you can measure the angles very properly or accurately. But here with the thick lines, I will draw a rough diagram. Here this is almost 25 degrees. So if I also take 25 degrees, it has to be somewhere through this. There. So if we draw the ray starting from here, it has to go through this particular point. Right. So that is the reflected ray. We have to mark the angle of refraction, and the angle of incidence will be equal to angle of refraction. So here students, since they have told us to mark the rays only, I am not labeling any of the rays. But you all know a ray coming towards the mirror is the incident ray, and that is going away is the reflected ray. So these are the ways in which different rays are reflected by concave mirrors. Now I will move on to the next one. Extra question 4. Draw ray diagrams to illustrate the image formed by a concave mirror for the given positions of the object. So first they have given the object between the center of curvature and focal point, that is between C and F. So this is for a concave mirror. Then how do we do that? We start by drawing the principal axis, then the mirror. Yes. So first we need to draw the principal axis. Then what do? We show the line for the mirror. So I will put the line somewhere here. And then what do? We have to draw a concave mirror. So concave mirror, we have to show the reflective and non-reflective surfaces. After that, what do? We need to mark the F and C. So you all know the distances. They have not given us any values. So I will take it as 5 centimeter and 10 centimeters, so that it is easy for us to draw the rays. Then we have to mark the points F and C, and the object is between C and F. So now to draw the object, I will draw it here and also mark it as O, object. Then what do? We have to draw two rays that are coming from the top of the object. So to do that, I will use a different color. Then you can understand the rays easily. So a ray coming parallel to the principal axis. A ray coming parallel to the principal axis. So that is the first ray. How does that reflect? That has to go through F. It has to go through F. So this will reflect through F. That is the first ray. Then I will take a ray that is coming through focal point, so that it will reflect parallel to the principal axis. So here so if it is coming through the focal point, it will come to this point, and then it has to reflect parallel to the principal axis. it will reflect parallel to the principal axis. So now we have drawn the two rays that are coming from the top of the object. And here you can see they both meet at this point. So where will you get the image? At the intersection of the two rays. So it has to be from here to here. That is the image. Now you can see this is the object between F and C. So object between the center of curvature and focal point, that is F and C. You get the image there. It is above C. It's inverted. Is it real? Yes, you can get it on the screen. And also it's larger than the object. So those are the properties, but here they have not asked for the properties. Then we will move on to the second type of image that they want us to draw. Object on the center of curvature. So again, the same method. You have to start with the principal axis. So the principal axis. So now we have to draw the mirror using the broken line, and also for that anyway I will use a ruler. So it will be somewhat more convenient for me. So now I'll draw the line for the mirror. So here this is to make sure that I draw a straight line. So now that I have the line for the mirror, then we have to show that that is the mirror. What do we do here? We draw the concave mirror. You all know we are drawing the ray diagram for concave mirrors. What is the next step? I am sure you have marked all the different points, the F and C. So you would have taken a certain measurement. I will take the distance as 5 centimeters and 10 centimeters. F at 5 and C at 10. So here I have the F at this point and C at this point. Okay. So I will have to write it as F and C. So here we are going to have the object also on C. To draw the object, now I will use a different color. So this is going to be the object. So you can also write it as O there. Then I will draw a ray that is coming parallel to the principal axis. A ray coming parallel to the principal axis. Yeah. So here I have drawn a ray coming parallel to the principal axis. You know what will happen to the ray? It will reflect through F. It has to reflect through F. So here. This has to go through F. Then what is the next step? We have to mark the direction of the rays to show what is the incident ray and what is the reflected ray. Then what is the second ray? We can use a ray coming through the F. Coming along F. So another ray going through F. So I will draw the ray. So what is the way that ray is going to reflect? It has to reflect parallel to the principal axis. So this has to reflect parallel to the principal axis. If we take it parallel to the principal axis, so from here it has to go that way. Now I have the two rays, and this is the point where they meet, and if we draw the image. So students, you all know when the object is on C, the image also has to be on C. As I told you all before, since these lines are very thick, I could not get the image exactly on point C. It's slightly slanted. But when you all draw, if you draw very thin lines, you will be able to draw the correct position for the image. It has to form on C. So the image and the object are on C. Image is inverted, the same size, and it will be real. So that is the object on the center of curvature. Now I will move on to the next one. Extra question 5. Write the characteristics of the image formed by a plane mirror. So I have to write the characteristics of the image formed by a plane mirror. What are the characteristics? It's upright. Is it real or virtual? It's virtual. Now you're very familiar with all these properties. What is the next one? Same distance. Distance of object equals the distance of the image from the mirror. So distance between image and mirror equals distance between mirror and object. What about the size? It's the same size as the object. Same size as the object. Let's see. Have we written everything? Upright, virtual, distance between image and mirror is equal to the distance between the mirror and the object, and also it is the same size as the object. We need to write one more. What is that? It is lateral inverted. You know what? Lateral inverted. If you raise your right hand in front of the mirror, plane mirror, the left hand of the image will be raised. So that is lateral inversion. What is the next one? Draw ray diagrams to illustrate the reflection of a parallel beam of light by a concave mirror and a convex mirror. So the next one, to show how reflection of a parallel beam of light by concave mirror and convex mirror. So both. So to do that, I will draw the ray diagram side by side. One for this one and for the other ray. Now let's use a ruler there to mark so this line is to denote the two mirrors. So those are the lines for the mirrors. Then we need to show what type of mirrors are here. I will draw the concave mirror here and the convex mirror there. So to draw the rays, I will use a different color. Then you can identify the rays easily. That is one ray. I will draw another ray coming parallel to the principal axis. So we have two rays. One is this, one is this. Both are parallel. What happens to these rays? They will converge. They will reflect and go through one point, the same point. What is that point called? It is the focal point of the mirror. So the same way we need to have the other ray going through the same point. It will go through the same point there. So this is one ray, that is the other ray. That will be the focal point. So what happens here? This is the concave mirror. Rays coming parallel converge through one point. Then what will happen to the convex mirror? Again we need to draw parallel rays. So to draw the parallel rays, right. Again I will use a different color so that it's easy for you all to differentiate the rays. So a ray coming parallel to the principal axis, another ray coming parallel to the principal axis. So those are the two rays. What will happen to these rays? They will be diverged. How do they get diverged? They get diverged in a manner that they will, when you extrapolate the rays, they meet at one point. So here I will draw the diverged ray. Then what do you need to do? We need to extrapolate the ray like that. So then we need to draw the second ray that also has to go through the same point. So here so this is one ray, this is the other. So those are the two rays. The rays that come parallel to the principal axis get diverged, but when you extrapolate them, they meet at this point. And what do we call that point? That is the focal point of the convex mirror. This is the convex mirror. So this is the reason why we call a concave mirror as the converging mirror and the convex mirror as the diverging mirror. The rays are diverged here, the rays are converged here. So I'm sure you got these also correctly. I will move on to the next one. Extra question 6. Draw the path of the rays given below as reflected by a convex mirror. So what we have here is a convex mirror. So the first one you can see that is coming along the principal axis. What happens to that ray? That reflects in the same path. Why? Because that is perpendicular to the surface of the mirror. So therefore, it reflects back in the same path. I can use a different color again to show that it reflects in the same path. So this is what happens to that ray. The next one. Here they have shown the ray coming along the principal axis, reflecting back through the same axis, and the ray that is coming towards the mirror. How does that reflect? It reflects away or diverges away from the mirror, so that when you extrapolate the ray, it will go through F. So to do that, I will need the ruler as well. So here we have the ruler. So it will diverge in such a way so here this is the ray that is going to diverge. From this point it will reflect away, but when you extrapolate the ray, it will look as if it's going through that. So that is the ray that I have to use. The ray that's coming parallel gets diverged. And students, you have to make sure that you diverge from this point where we have the line. So that is how we draw the two rays here. With that, I'll go on to the next one. That is this ray. A ray coming along the focal point. How will that reflect? That will reflect parallel to the principal axis. So here it has to reflect parallel to the principal axis. It will reflect from this point parallel to the principal axis. So this will be the reflected ray. Then we have another one. A ray coming towards the center of curvature. What happens to that ray? That also reflects back in the same path. Why? Again, that is perpendicular to the surface of the mirror. So here it will reflect back in the same path. So here we have completed all the different rays that are reflected by a convex mirror. With that, I will move on to the next one. Extra question 7. Why do light rays refract when they travel from one medium to another? I am sure you know this answer. Why do they refract? Because one medium is rarer and the other medium is denser, or one is denser and the second medium is rarer. When they go from one medium to the other, what changes? The speed of light changes. Because of that, the light deviates from its path or bends from its path. That is what we call as refraction. So that is what you have to write there. So we will have to say, why do light rays refract when they travel from one medium to the other? So we can say when light travels from one medium to another, the speed of light changes. Therefore, it bends from the path. So here, why do light rays refract when they travel from one medium to the another? So this is the reason. Because the speed changes, they bend from their normal path. So then I will move on to the next question. Extra question 8. The diagram given below illustrates the path of a light ray refracted through a block of glass. So here you can see a block of glass. I am sure immediately you are able to identify we did this activity and you drew this ray diagram before also, so you know what this is. The diagram given below illustrates the path of a light ray refracted through a block of glass. Use the letters given in the diagram relevant to the following. So we need to identify all these: incident ray, refracted ray, emergent ray. So here you can see this is the incident ray AB. Then what happens? It refracts at this point. So BC is the refracted ray. And what comes out of the block of glass is the emergent ray. Emergent ray CD. And if you look at it, you can see AB is incident at this point and XY is the normal there. I is the angle of incidence. And how does it refract? It bends towards the normal. Here R is smaller. Then again it's incident here at this point. MN is the normal. It bends away from the normal. And this is the angle of emergence. So then we have to write the angle of incidence, angle of refraction and angle of emergence. Angle of incidence is they have said use the letters given in the diagram relevant to the following. So we can either write it as I or you can write the angle as ABX. You know how you write angles. Then what is the angle of refraction? That is R, or you can say YBC. It will be YBC. That is the angle of refraction. Then angle of emergence. This is the emergent ray between the normal and the emergent ray. That is E, or we can write it as DCN. DCN. So AB, BC, CD, those are the different rays. And these three are the different angles. So you have identified all the rays and the angles. With that, I will move on to the next question. Explain briefly how the light ray is refracted in the diagram above. So the diagram that we saw before. You can remember what happens there, but I will go back to the slide just to show you all. AB is the incident ray. It refracts towards the normal. Why? Air is lighter or rarer medium and glass is the denser medium. And at this point where you have the MN, that is the normal, from there the ray refracts away from the normal. Why? Glass is the denser medium, air is the lighter medium. So that is what we have to explain here. Explain briefly how the light ray is refracted in the diagram above. So to do that, we have to say when it enters the glass block, it refracts towards the normal. The light ray is refracted. Then when it exits or when it emerges from the block of glass, when it emerges from the glass block, it refracts away from the normal. So that is what happens to the ray. So they have asked, explain briefly how the light ray is refracted in the diagram above. So you have mentioned whether it's towards the normal or away from the normal. Then the next question. What is the conclusion of the above activity? So what can we conclude from the above activity? When light rays travel from a rare medium into a denser medium, they bend towards the normal. From a denser medium into a rarer medium, they bend away from the normal. That is what you can conclude. And also we know that there is refraction taking place. You can also include that. So we can say path of light changes when it travels from one medium to another. That is one. Then the second one, light bends towards the normal when traveling from a rare medium into a denser medium. That is one. Then we can write the other conclusion. What is the other conclusion? Light bends away from the normal when traveling from a denser medium into a rarer medium. So here we can say light bends away from the normal when traveling from a denser medium into a rare medium. So you were able to observe all these from the previous diagram. And I'm sure you can remember what happened when we did the activity also. So that's very, very clear to you all. With that, I will move on to the next one. Extra question 9. Draw ray diagrams for the instances given below. Again, ray diagrams, light traveling from a dense medium to a rare medium. So this is what we explained now. So light traveling from a dense medium to a rare medium. We have to show what is the dense medium, and this is a rare medium. And then we have to show the light rays. Again, I can use different colors. Then it's easy. A ray that is incident like this. And the normal will be here. So this is a denser medium. This is a rarer medium. So the ray refracts away from the normal. And this is the angle of incidence. This is the angle of refraction. Angle of refraction, and this is the incident ray and the refracted ray. That is this. So light traveling from a dense medium to a rare medium, and this is the normal. Then a light traveling from a rare medium to a dense medium. So you know that has to be different from this first one. Again we draw the interface, and I will use a different color to denote the rays. So again a ray coming like this. We need to have the normal here. And before I draw the ray diagram, we have to show which is the dense medium and what is the rare medium. So a light traveling from a rare medium to a dense medium. Then what will happen to the ray? Rare to dense, it will refract towards the normal. So this is the incident ray, this is the refracted ray, and that is the normal. So incident ray, angle of incidence, angle of refraction, this is the normal, and this is the refracted ray. And the angle of refraction. So you can see the difference between the two ray diagrams. Here it refracts away from the normal, here it refracts towards the normal. Is this the only way you can draw the ray diagrams? No. You can have the denser medium below and the rarer medium above. Same thing for this. Then the ray has to go from here into the second medium. Both are possible. When I explain the lesson, I have shown you all that. So you can use any way. It's just that you have to show that here from the dense medium it's coming to the rare medium. Here from the rare medium it's going into the denser medium. And you have to be careful as to how it bends. Whether it bends towards the normal or away from the norm. So with that, I will move on to the next question. Extra question 10. Write the properties of the image formed by a convex mirror. You all know convex mirrors always form the same type of image irrespective of the position of the object. What type of image is that? It is upright, it's virtual, and also they are diminished or smaller than the object. That is why we discussed before, it's very useful as side mirrors of vehicles. So those are the properties. Write the properties of the image formed by a convex mirror. So here properties: upright, virtual, smaller than the object. So those are the properties of the image formed by a convex mirror. I will move on to the next one. What is total internal reflection? What is total internal reflection? When light is traveling from a denser medium into a rarer medium, and if the angle of incidence is greater than the critical angle of that medium, light does not refract. Instead, it reflects within the same medium, and that is known as total internal reflection. And that is what you have to write here. I am sure you have written it correctly even before I discuss the answer. So, what is total internal refraction? When light travels from a denser medium to a rare medium with an angle of incidence greater than critical angle. It does not refract. Instead, reflects within the dense medium. This is known as total internal reflection. So this is to answer what total internal reflection is. With that, I will move on to the next one. Extra question 11. What is a critical angle? Use a ray diagram to illustrate the critical angle. What is a critical angle? The angle of incidence when the angle of refraction is 90 degrees. When does that happen? When light rays are traveling from a denser medium into a rare medium. So that is the answer to this first part of the question. We will write that down first. So when light travels from a denser medium to a rare medium, the angle of incidence when the angle of refraction is equal to 90 degrees is known as critical angle. So that is the answer to the first question. Use a ray diagram to illustrate the critical angle. I am sure you can do that. So what do we need to draw? We need to show the interface first, and then we need to say what is the denser medium and what is the rare medium. So here this is the dense medium and this is the rare medium. Again, I will use a different color to show the rays. Then it is easy. So here we have the incident ray, and this point we have the normal, and when it reflects, it goes along the interface. And at this point, this is the critical angle. Incident angle is the critical angle. So this is how you show the ray diagram. When a light ray is going from a dense medium into a rarer medium, you increase the angle of incidence, angle of refraction increases, and at one point the refracted ray goes along the interface. That is, this angle is 90 degrees. At that point, the angle of incidence is known as the critical angle. C is the critical angle. So that is the answer for this question. We explain what critical angle is and we have shown it using a ray diagram. So with that, I will move on to the next one. Extra question 12. A biconcave lens always forms a diminished, upright and virtual image of the object. Draw a ray diagram to illustrate this observation. So this is a biconcave lens that always forms a diminished, upright and virtual image. For that, we have to draw a ray diagram. So where do we start? Always we have to draw the principal axis first. So I will start off with the principal axis. So here we can draw the principal axis. Then what do? We need to draw the line to indicate the lens. So that is a broken line that I am drawing. Then after that, we need to show what type of lens is there. So this is the biconcave lens. Then what do? We need to mark the 2 points. What are those points? We have to mark the F and 2F on either side of the lens. F2F, F and 2F. So after that, we can place the object anywhere. A biconcave lens always forms a diminished, upright and virtual image of the object. Draw a ray diagram to illustrate this observation. So I will mark F dash to F dash, F and 2f there. Let's say we will draw an object between f and 2f. So that is the object. Now we have to have rays coming from the top of the object. So I will draw a ray that is coming parallel to the principal axis. So again I'll use a different color. What will happen to this ray? It will refract away from the ray. So when it refracts, it will look as if it's going through the focal point. It has to refract in such a way that it will look as if it's going through the focal point. So here it's going to refract away like that. It's going to refract away like that. But when you extrapolate, it has to go through F. Then what happens? Another ray that is coming another ray has to be drawn. Before that I will mark the directions. A ray that is coming through the optical center travels along the optical center without undergoing bending. So that also can be taken a ray coming through the optical center. So if we draw this ray, that will go like that. So there is no change in the path of that particular ray. It will go this way. So where does the image form? Here we have the object. The image is going to be here. So that is the image. We have the object here, image. Now can you show this? It's diminished. See the size of the object and the image. It's upright. Yes, it is upright. And also it's virtual. Why? It's between the lens and the object. So you have to look from this side through the lens to look at the object. I'm sure you can remember seeing this image when we did the activity. So you know it is a virtual image. We were unable to get it on the screen. So here it is a virtual image. So using this we can explain all the properties. Draw a ray diagram to illustrate this observation. Even if you have the object in a different place, you will get an image similar to this. It will be always upright, virtual and diminished. With that, I will move on to the next question. Extra question 13. Write the position of the object when a biconvex lens acts as a magnifying glass. You all know it's also called a hand lens or a simple microscope. Why do we use it? To magnify the object. When we read a book, if the letters are very tiny, we hold the hand lens so that it looks larger. So where does the image form? It is beyond the object on the same side as the object. So that is why you get a virtual, enlarged, upright image. So write the position of the object when a biconvex lens acts as a magnifying glass. Here we only need to write the position. So what is the position? I explain the position of the image. Where will the object be? the object has to be between the lens and the focal point in order to get this type of image. So, here write the position of the object. So, you have to say between the lens and the focal point. Then only you will get an enlarged, upright, virtual image. So, then the next question, draw a ray diagram to illustrate the above instance. So, we have to draw a ray diagram. Now, you are very familiar with drawing ray diagrams. I am sure you can do it very quickly and accurately. I will start off with drawing the principal axis. Then to mark the lens, and we have to write we have to show what the lens is, a biconvex lens. What's the next step? I'm sure you know that. To mark the points. So again, to mark F, need to mark F, then 2F and F and 2F on this side as well. So we just need to write F, 2F, F dash, 2F dash. So those are the points that we need to mark. Then we need to show that when the object is between the lens and focal point, you get an image that is upright, virtual and enlarged, and it has to be beyond the object, on the same side as the object. So to do that, I will draw the object somewhere here. So we have the object there, that is the object. First we will draw a ray that is coming parallel to the principal axis. So that will reflect through the focal point. The ray will reflect through the focal point there. And by now you know the image has to form on that side. So we need to extrapolate the ray as well. So I will do that as well. The ray has to be extrapolated like that. So that is one ray. So a ray coming parallel to the principal axis refracts through focal point, and here we need to extrapolate it as well. Then a ray coming through the optical center. I will consider a ray coming through the optical center. So that will go through the optical center without any change in the path, and we have to extrapolate that as well. So to do that, I will again use the broken line. Okay. So here we have the image forming there. That is the image. So object is here, image is there. The ray coming this way. So that is the ray diagram to illustrate the above instance. You can see it's upright, enlarged or magnified, and it is virtual. So now we will move on to the next question. Extra question 40. What is the center of curvature of a concave mirror? What is the center of curvature of a concave mirror? Can you all remember that? How do we get a concave mirror? We take a hypothetical sphere, and from the hypothetical sphere we take part of the mirror. So the center of that sphere is the center of curvature of a concave mirror. So that is what we have to write here. The concave mirror is taken from a hypothetical sphere. The center of that sphere is the center of curvature of the concave mirror. So they have asked what is the center of curvature of a concave mirror. You can write it. If you want your answer to be more clear, you can also represent it in a diagram. I will show that as well. So here we need to have a sphere. So this is a hypothetical sphere. So this is the hypothetical sphere. I will draw the concave mirror in this. So if we take this as the concave mirror, the reflective surface is inside the, or it curved inwards, and this is the center of this hypothetical sphere, and that is the center of curvature of this mirror. So this is termed as C. C is the center of curvature. So if you find it difficult to only explain, you can use a diagram as well. So with that, I will move on to the next question. Extra question 15. Explain refraction of light. You all know what refraction of light is. How do you write the answer? When light rays travel from one medium into another, the path of light changes, or they bend from their path, and that is refraction of light. So that is what you have to write here. When traveling from one medium to another light bends from its path. Why does this happen? Due to change in speed of light, and this is refraction of light. Then we need to write the first law of refraction of light. What is the first law of refraction of light? What is it? The incident ray, the refracted ray, and the normal at the point of incidence are all in the same plane. That's the first law. So, the incident ray, refracted ray, and the normal at the point of incidence are on the same plane. So that is the first law of refraction. Write the second law of refraction of light. What is the second law of refraction of light? I am sure you can remember this. We give a special name to this law as well, the Snell's law. What does the Snell's law say? The ratio between the sign value of angle of incidence and the sign value of angle of refraction is a constant for the two media. So that is the second law of refraction of light. So the ratio between the sign of I, that is angle of incidence, and sign of R, that is angle of refraction, is a constant for the two particular media. And what do we call that constant? As the refractive index. And this is known as refractive index. So that is the second law of refraction. With that, I'll move on to the next question. Extra question 16. When a page of a book is viewed through a block of glass placed on it, the script on the page seems to be raised up a little. Why? The light rays that travel from the script of the book, they come through the block of glass and then they have to exit from the block and come through the air medium. So there are two media involved, the glass and air. So glass is a denser medium and air is the rarer medium. Therefore, the speed of light changes and light undergoes refraction. So that is what we have to write here. So we can say light rays from the script travel through glass and enter the air medium. The speed of light will change and the rays will bend from their path. That is light will reflect. Therefore, the script looks raised from the position. So that is the reason. You know this very well. We have observed it in many instances. For example, the activity with a block of glass. I told you all some examples. So that is how this happens. With that, I will move on to the next one. Extra question 70. A light ray can undergo total internal refraction through a right angle prism. Draw a ray diagram to illustrate this observation. What is a right angle prism? A prism that has a 90 degrees angle. So to show that light rays undergo total internal refraction. So we have another, and here we have this. So this is the right angle. What are these angles? 45 degrees. 45 degrees. And what is the critical angle of glass? Critical angle of glass 42 degrees. And when light ray, I will use a different color, travels perpendicular to one surface. Here this is a 90 degrees angle, so it's perpendicular to the surface of the prism. Therefore, it does not refract. It goes straight. And then when it falls on this point, if we draw the normal there, what is this angle? That is going to be greater than the critical angle. So then what will happen? the light ray will not refract. Instead, it will undergo total internal reflection with the same angle. So, the ray will come out like that. So, that is the ray. So, if we write down, this is the ray going and this is the emergent ray. And here you can see it has been bent by an angle of 90 degrees. So, a light ray can undergo total internal refraction through a right angle prism. Draw a ray diagram to illustrate this observation. So, here this is what happens there. And these are the two angles, angle of incidence and angle of refraction. I is equal to R and it is greater than C. That is the critical angle. And this is how the total internal reflection takes place. So, with that, I will move on to the next one. Extra question 18. Draw ray diagrams to illustrate the image formed by a biconvex lens for the instances given below. So, you are given two instances when the object is between the lens and the focal point and when the object is on the focal point. So, you are very familiar and I am sure you can draw the ray diagrams well. So, first you all draw the ray diagram and then compare with my diagram. I will start off by drawing the principal axis. So, I will draw the principal axis first. Then what do? We need to draw a line where we have the lens and also we have to draw the lens. Here it has to be a biconvex lens. So, it's a biconvex lens like that. Then we need to have the points. What are the points you need to mark? Again, I will mark F, 2F, F and 2F. Right. So, we have marked 2F dash, F dash, F, 2F. Then we need to draw the object between the lens and the focal point. So, I will use a different color, the lens and the focal point. So, that is the object. Oh, then what do? We need to draw the rays that are coming from the object. So, you know what to do. A ray coming parallel to the principal axis. So, that is the first one. How does that? It has to refract through the focal point. So, here it has to refract through this point and you know we have to extrapolate that line because you are very familiar with drawing the ray diagrams. You all know here the image has to be a formed behind the object. And then what do? A ray that is coming through the optical center. that again. A ray coming through the optical center, what will happen to that ray? It will go through without any change. So the ray coming through the optical center, that will go like that. Again, we have to extrapolate that ray. So when we do that, you can see the two rays meet at this point. So you will get the image here. So that is the object and this is the image. You can see it's an upright, enlarged virtual image further away from the object on the same side as the object. So you have to look through the lens to see this image. And you know where we use it. We have discussed many times in the previous questions. The hand lens or the magnifying glass. So with that, I will move on to the next one. The next, when the object is on the focal point. You all know very well how the image forms. It forms at infinity. So if you can remember where the object will form and how it forms, it will be very easy for us to draw the ray diagram. Anyway, we have to start off with the principal axis. So here I will need to draw a line, a straight line for the principal axis. Then after that we have to draw the line for the lens. Then what do? We need to mark the focal point and center of curvature. So here we will take it as 3. Now I am using different values for the focal point and center of curvature. You have to write what they are. 2F dash, F dash, F and 2F. Then what do? We have the object on the focal point. So again I will use a different color for the object, and here the object is on the focal point. Then what do? We need to draw the rays coming from the top of the object. So here if I take a ray that is coming parallel to the principal axis, that's one. And what happens to that ray? Now you are very familiar with all these observations. It refracts through the focal point. So here we will draw a ray that reflects through the focal point. Then what happens? We need to draw another ray. I haven't drawn the lens. So this can happen to anyone. What do you need to do after we draw the line? I have shown the line, but it's better to draw the lens. So I will draw the lens here, biconvex lens. So this is something that you have to remember, students. You can use the line. It is specified here that it is the biconvex lens in the question. It was there above, but still it's always better to draw the lens there. Then we take a ray that is coming through the optical center. a ray that is going through the optical center. So if I draw that you know does not bend. It goes through the optical center. So you know these two rays will not meet. What do? We do extrapolate the rays to show that they won't meet. This is one and this is the other one. They will be going parallel to each other. So the image will form at infinity. Only thing is we have to show the direction of the light rays. The ray coming this way, it goes straight. So that is how the image of an object at the focal point will form. It will form at infinity. Then the next question. I am sure you have got all these diagrams correctly. So with that, I will move on to the next question. When the object distance is equal to twice the focal length. So that is the third ray diagram that we have to draw. So here again, I start with the principal axis. Again, we need to draw the line for the lens, and now without forgetting what do you draw, you have to draw the lens. What type of lens is this? A biconvex lens. Then what do? You mark the different points. So here we have 2F, F, again F and 2F, and the object is also on to F. So here again we have to draw the ray diagram. So before I do that, this is to F dash, F dash, F, 2F. I will write the 2F there, and you know the object is this. So I'm using a different color for the object. Now we will draw a ray that is parallel to the principal axis. A ray that is coming parallel to the principal axis, that has to reflect through the focal point. Will reflect through the focal point. Then what do? We use a ray that is coming through the optical center. Okay. A ray coming through the optical center. Go straight like that. It does not undergo bending. So where do you get the object? Get the image there. So on 2F itself, we have the object here, we have the image here. And also you all know the size of the object and the size of the image are equal. What is missing in this diagram? We have to show the direction of the rays. A ray coming parallel refracts through the focal point. A ray coming through the optical center travels in the same path. And the point where they intersect, we get the image. Same size, inverted real. And also that is also on 2f, twice the focal length. So that is the ray diagram for this particular question. And with that, I have come to the end of extra questions. So now we started off the lesson with plane mirrors, then we discussed curved mirrors, concave and convex mirrors and their uses. Then we discussed what refraction of light is. After that, we discussed the total internal reflection and applications of that. And thereafter, the two types of lenses, convex and concave lenses, and how they form images. And you all are very familiar with drawing ray diagrams. And finally, the uses of different lenses in different optical devices. So after that, we did a lot of questions from your textbook as well as all these extra questions. So I am sure with all these practice and after drawing so many ray diagrams, you will be very clear as to how to draw a ray diagram, and you have understood all the different types of images formed by the mirrors as well as the lenses. But even with that, you have to read the textbook again. You have to listen to the discussion if you need to clarify more, and also you have to practice drawing ray diagrams and answering questions so that you will become very competent to answer any type of question given related to this lesson.